So today I'm going to talk about Firehose high availability. Actually, that was what I was planning to do. And then it's like, oh, well, I need to talk about substreams too, especially given the discussion about GGP 0025. So let's go to the first slide. All right, so agenda for today, what are Firehose and substreams? Quick review, the architecture, then we'll get into the main topic, which was high availability, and let's talk about also GIP 042 and cooperating with other interests to deploy this stack. All right, so first slide, next slide. All right, so what is Firehose? We've seen this slide in a few previous presentations, so I'm not going to go through this in detail. If you want to know more details about what is Firehose and you haven't heard about it before, then please review the previous IOH sessions where we talk about Firehose. So the main thing here is Firehose is extracting all the data out of the blockchain and dumping it into flat files sitting on disk. And having flat files allows us to do massive parallel processing if you've got an architecture that will support it for things like substreams. Next. So what is a substream? Okay, so when you use Firehose, Firehose sends you the entire block, if you like. With the indexes that are implemented in Firehose, you can actually get it to filter stuff. But in general, Firehose sends you the entire block. With substreams, you can get it to just send just the information that you just want for whatever application that you're building. So substreams are composable. Unlike subgraphs, where every developer has their own subgraph, with substreams, you can actually build on top of another person's substream. So one thing that we're going to need in the future is a substream registry where everybody can see the different substreams that are available, and you can say, oh, I want to build something based on whatever that's already there, and then at least you don't have to understand the details of how that other thing works. You can just build something on top of it. So that's going to be a great thing for developers. They're parameterizable. So if you have a substream that takes parameters, then you can just feed it details. So instead of, for example, getting all token transfers, get token transfers for your specific account. Would be an idea of a parameterizable thing. Substreams are transformable. So that means the output format out of the substream when you request data can be in different format. So most of the time in this, when we're talking about the graph, it's going in the format that's required to ingest into GraphNode. But you don't have to put it in GraphNode. You can put substreams in a sink of your choice. So it could go in MongoDB or Postgres or, just send it out to Prometheus and just generate some charts in Grafana. And substreams are parallelizable. Okay. So blocks are processed in chunks and then the results gets merged. Next slide. Okay, so the data pipeline for a developer, I'm explaining all this because this goes to understanding how it works so that you know how the implications on the deployment architecture. So what do we got? So we have ETLQ. So this is a standard pipeline of data extraction, transformation, loading, and querying. So the extract process is done by Firehose. The transform, so Firehose is creating the flat files. Then Substreams is reading those flat files and transforming it into the output format that you want as a developer. So the developer decides how they want their output. And then we load it into some storage somewhere. So for example, GraphNode or anywhere else. And then that storage location then provides a query layer, or it doesn't, depending on however that thing works. So ETLQ. So just so you understand where Firehose and substreams fit into the overall data transformation process. Next slide. So where do you want to store all that stuff? So this is just like a kind of a word storm here. Store it in Postgres, GraphNode, key value store, stream it somewhere else, CSV file, wherever. The amount of different outputs for substreams is growing every month. We see developers building new ones. So next. Okay, we've seen this architecture diagram in the past, except I added one new box in here, which is the substreams tier 2, which is at the middle left side there. So when a user connects to Firehose or GraphNode connects to Firehose, it will then send a request to the substreams tier 2 to process the chunks of blocks for your substream. The remainder of the architecture looks exactly the same as before. So you can request data through Firehose, which works the same way. Or if you send the substream request, then it will process it as a substream and then evaluate the results. I should be clear, there's one line missing from the diagram, which I kind of left out on purpose. The substream tier 2 does need access to the archive node in case you're doing ETH calls. If you're not doing eCalls, then it doesn't get access to archive node. But yeah, there's a missing line there. All right, next slide. So let's just go through the workflow, kind of what I said quickly, just in detail. So the user or graph node or whatever connects to Firehose gRPC. Firehose chops up the requests into block ranges and sends them to the substreams tier 2. The block size is configurable, like 10,000 blocks in a chunk. The number of parallel threads is configurable. So if you have more hardware, if you have a cloud, this can go very, very big. If you have a small installation, well, you have less processes. Each substream's tier 2 runs all the calculations it needs and then writes the results back to the object store. So the results don't go back to Firehose, they go back to the object store. And while it's doing calculations, it's sending progress messages back to Firehose. And Firehose is sending those progress messages back to the user so you can see where you are in progress. And then when it's done, it sends, hey, all finished. And then the Firehose can then retrieve the data from the object store and send it back to the user. The results remain in the object store for future use. So if the developer comes along an hour later, a week later, and requests the exact same substream, well, guess what? We already have the results calculated. We can just send them back. And since substreams are composable, it's actually cached at the module level. So we're going to see that in the next screenshot. But each module is cached independently. So if a developer builds on top of something else that was already cached, well, great, it will run faster because we can already use those. We don't have to recalculate those pieces that are already available. When running live, so if you're up to the current blocks, then the tier 2 is not used. It just runs the substream as part of the Firehose process. The tier 2 is optional. If you don't have it, well, then you don't get the massive parallel processing. Next slide. Okay, so here's a view of the USWAP v3. So I ran this a couple of weeks back, and this is the output the developer gets on their screen as the process is running. So you can see the progress indicator. So a dark green bar is it done. The kind of middle color is it's in progress, and the light ones, it hasn't started yet. So, and the maps are listed on the left. I know the font's a bit small there, but this is just kind of the idea of how it works. So if you run the command listed there at the bottom, and localhost 9000 is actually your Firehose endpoint, with substreams enabled, there is a configuration flag you need for that. If you pass this, then you'll actually see the output and it will start using all the CPU you have available. Next slide. Okay, so let's talk about the goals of the high availability deployment. So there's a few different things we want to think about. We have component upgrades. Aragon nodes need to be upgraded. Firehose needs to be upgraded. If in case there's software improvements, we have to rebuild all the blocks. Hopefully that doesn't happen very often, but it does happen from time to time. Of course, things go wrong. Hardware dies. Want to handle that kind of case. And then for the purposes of substreams, the more hardware we can throw at it, the faster it's going to compute a newly created or newly requested substream. Next. So here's when I was running, here's the CPU or the resources chart that I put together. So it's like running, 150 odd CPU cores and using 164 gigs of RAM and then the bandwidth to the storage server. So this is just, I added up, there was 4 machines allocated to processing substreams. So I just added up the whole usage. So you can see on the bottom chart is the network utilization going back and forth to the storage server. You can see it's reading all the blocks, but the actual number of writes is actually quite small, at least for this substream. Other substreams might write more data, but the yellow downward is much smaller than the green upwards on that bottom chart. Next. Okay, so just going back to our little diagram from before, changed it a little bit here to put little boxes behind the things that you have multiple of. So we have multiple Firehose gRPC endpoints, multiple relayers, multiple substreams too. The Firehose-enabled execution node, reader, consensus node, those things are a bit, well, I don't know what we call it, weird, because depending on which blockchain you're running, how that architecture looks is dependent on how that blockchain was. If you're running with Ethereum, then you kind of need consensus node, Firehose-enabled execution node, and reader as a triplet. So you need all 3 of those as a cluster together. So just to say, the architecture of how the high availability for the blockchain parts work depends on which blockchain you're on. But otherwise, yeah, here we go. Next. So what's the best way to set things up? Unfortunately, I don't have a universal answer for you. It depends. What kind of services do you plan to offer? Are you just using it for your own use, or are you going to plan to make your Firehose publicly available? What kind of environment do you have? Is this on bare metal? Is it on cloud? Lots of different things to set this up. There's lots of different ways to set this up. You'll need to help figure out what works for your environment and what services you plan to offer. We're happy to help discuss. I know that a few indexers have set up high availability solutions already. Good discussions in the Indexer Firehose channel, so feel free to ask. Also, this is an evolving tech stack. If you looked at the blog post from Streaming Fast from last week, where they're listing the different things that they're working on for June, then you can see that they're working on evolving the Substreams Tier 2 backend to improve it. So based on the developer feedback, based on indexer feedback, this tech stack will keep improving. And as we discussed earlier, GGP 0025 substreams are coming on the network soon. So hopefully you're interested and ready to run this. Next slide. Okay, storage. Usually you want to keep one copy of the Firehose block. So unlike running a blockchain node where you have to kind of clone the entire infrastructure and you make an exact copy of it, here we're not making a copy of the object store. There's only one object store. And all the different components access the same object store. The object store does need to be shared so that all those different components can access to it. But, you can run the object store on a cloud provider. You can do it on Ceph like we do. Somebody else runs it on Seaweed. Other people are using NFS. So, variety of different solutions you could use to share data. I mean, you could replicate the Firehose blocks across multiple locations. That also works too. That makes it a very simple setup, but you're not getting the advantages of reusing the blocks across multiple servers. Next, connectivity. Okay, so let's talk about how do we connect all these components. So probably if you're going to start running multiple Firehose gRPC endpoints to handle load, then you're going to want a load balancer. So in our case, we use Nginx. Other people might do different things. So there's the incoming component where you need to load balance Firehose. There's also connections between all the different components. And then you need a way to distribute load to the Substreams Tier 2. So you could connect all these things manually, specify the IP address and port, do DNS. We use service discovery in console. You can create a proxy server, or I know other people use XDS with Google Traffic Director or Envoy Proxy or something like that. So depending on your thought process of how big you want to get, it might inform different ways of selecting different things. So yeah, we use Nginx as our incoming load balancer to Firehose. Nginx does proxy gRPC connections okay. We are looking at Envoy to how to do the internal routing to the Tier 2. But it's not really routing because it's really directing the traffic based on load. Currently, we're using DNS round robin for that, which doesn't exactly distribute the load evenly across the different backend Tier 2 nodes. Okay, so the other thing is maybe you want to run part of the stack yourself and work with another indexer to run other parts of the stack. So the idea going forward as part of GIP 0042, a world of data services, is that indexers are going to come in variety shapes and sizes. So, for example, at Pinax, we spend a lot of time working on Firehose and substreams and a bit less time working on the kind of quote-unquote traditional GraphQL graph node infrastructure. Other indexers may make, the reverse decision. There may be more opportunities to run more different things in GIP 0042 in the coming years. So in general, it doesn't make financial sense for every indexer to run a full stack of Firehose for all the different blockchains that we're going to ever have available in the graph. It just does, some ecosystems in the graph are just not big enough to make that makes a cost-effective decision. So we need a way to allow indexers to cooperate with each other. And maybe one indexer wants to generate subgraphs for a certain blockchain, but use a different provider's Firehose, or maybe they want to run Firehose and they outsource the substreams part. So anyway, in the future, we see a lot of different indexers configured different ways depending on which components they want to use on which blockchains. Next slide. So here it's just a kind of visual example of kind of what I'm explaining. So indexer A has a graph node, and they're running a Phantom archive node and Avalanche node, and they're running an Ethereum Firehose. And the indexer B in the middle is using the Airweave Firehose from indexer A, and they're running their own Ethereum Firehose, and they're using Firehose for Polygon from indexer C. Should be possible. Indexer C is not even running GraphNode. They're just running a public API for Firehose and substrings potentially. So this is the kind of architectures that we need to think about as indexers in the future. Next, other considerations. So hopefully everybody already set up Prometheus. If you didn't, please go back, review previous slides, set up Prometheus. It's going to help you a lot. And I mentioned this other thing before is sometimes we have to reprocess Firehose blocks. So I would recommend that whenever you set up your object store that you stick a version number on the blocks. So we've got the blockchain name, which probably you've already put there, as well as a version number. The version number can be anything, just be what, X, Y, Z, whatever you want to call it. That way you can use your same object store to store a new version of the blocks in case they're needed in the future. That's it. We're at the end of the slides. So if there's documentation is on firehose.streamingfast.io and substreams.streamingfast.io. There's not too much on high availability there, but we're happy to discuss more in the Indexer Firehose channel, and we'll start adding more information on how indexers should set things up in the future.
Wonderful. Thank you so much, Matt, for going through all of that in the presentation right there. We have a question from Vincent, which I've highlighted here. So if you want, you can go ahead and address that one there.
So how important is it for the speed the Firehose gRPC's close proximity latency to substream? Can you get away with higher latency? Well, so yes, you can get away with higher latency there. The key thing is that both Firehose gRPC and the substreams are going to use those block files. So the really important part is they both have access to the blocks. Now, if substreams has a bit of latency on accessing the blocks, the tier 2 node, not too big a deal. It's just going to process it a little bit slower. But you do need to watch out for the bandwidth costs, so you probably don't want to store your blocks, for example, in AWS and run, your substreams tier 2 in Hetzner because, the egress costs out of AWS would kill you. So, look at the cost. So the whole point of substreams tier 2 is to support the massive parallelization. So if you looked at some tweets recently or, Alex's blog post from last week, we processed Uniswap v3 and loaded it all into GraphNode in 20 hours. Yeah, that's cool. It loaded in 20 hours. But how many tier 2 nodes were required in order to make that happen? Well, quite a lot. I don't know exactly how many, but you can see we had, a lot of CPU cores allocated to that. And I think ours took a bit longer than the Streaming Fast team. I'm not exactly sure how long theirs took. I think theirs took like 10 hours or something. And ours was probably more like 15 or 20 hours. But anyway, so look at the number of tier 2 nodes you want to deploy just directly correlates to how fast you can process a substream-based subgraph. The 20 hours was with GraphNode, but using GraphLoad, I believe. So GraphLoad is the way of you run Firehose substreams, you dump all the output into basically a CSV file, and then you bulk import it into Postgres. So, okay, do we need archive node calls with substreams? Since Firehose did not do archive calls. Okay, so if your substream uses ETH call, then you do need an archive node. If your substream does not use ETH node, then you don't need an archive node. So that's the requirement. So eventually there will be, we've talked about before, this thing called EVMX. EVMX just stores all the results for the archive, for the ETH calls. So in that case, you wouldn't need an archive node, but not for now, yes, you still need an archive node. So you need to hook up Firehose to the archive node as well as the substreams tier 2, both to the archive node, process ETH calls. If you're doing Firehose and substreams on a non-Ethereum blockchain, so say, for example, Cosmos, then this concept doesn't exist. You don't need an archive node of Cosmos in order to process substreams on Cosmos. Would you say latency between normal subgraph graph node and archive node is more important than latency between Firehose, gRPC, and substreams? I would say yes, but I don't have data that proves it one way or another. When Wreath Firehose, don't know about that one. There is a project to work on Aragon Firehose. Don't know anything about it.
Have you tried Wreath?
I have not tried it. Is it good?
Apparently.
Yeah, so keep us, for those of you who are trying Wreath, keep us informed. Let us know how it's going. I'm interested. Does EVMX implementation requires changes in the blockchain node client? No. EVMX is populated from Firehose itself. So the data goes from Firehose into EVMX. Any recommendation on the maximum number of tier 2 jobs versus the number of tier 2 nodes? I think about 8 jobs per node, if I remember correctly, is the recommendation. So if you've got a full machine, then, you could support. Well, it really depends on the amount of CPU cores, of course, you have. So, but yeah, you don't want to like put that you have a machine with, 100 CPU cores on it. You don't want to probably just have one tier 2 node on that. But definitely you want to have enough parallel process to use up all the CPU that you have. So on my, 50 core machines, I had like 2 or 3 tier 2s, I think. And then I ran like 300 threads. The other question seems like we're out of questions for now. So Abel, I'll hand it back over to you.
Amazing. Thank you so much.